Hello everyone, welcome to 1000 Math 7. This is the second video or part 2 of the first chapter of class 11 maths of the CBSE curriculum. Okay, so I hope each of you watching this video now have watched the first video and got to understand what is a set or what is the meaning of set and how we represent a set in the roster form or tabular form and in the set builder form as well. Alright, today we'll go ahead and try to learn more about sets. In fact, today we will see the different type of sets. Yes, sets can be of different types based on the number of elements it has or objects it has or how is it when compared to some other sets. Okay, so first of all, let us learn about empty set. Empty set. So as the name goes, empty means a set will be called as an empty set if it has no elements or no objects in it, right? If a set has no elements or no objects in it, it is called as empty set. Okay, this is very simple, empty set. But look carefully, there are some important points. So let's take an example here. Okay, let's say the set of, okay, let's try to take an example here. Let's say the set of the states in India. Okay, in India is our country. So the set of states in India that does not have a state capital. Okay, let's try to form this set and let the name of the set be S. Okay, so when you try to write the elements of this set, okay, S is equal to, if we try to write it in the roster form, we need to write what? The name of the states that doesn't have a state capital. But if you know that there is no state in India that does not have a state capital, each and every state in India has a capital, right? So this set will be an empty set. And how will we write it? Just two curly braces and no elements inside it, or else we can write it as S is equal to phi. This symbol, okay, this is called as, the name of the symbol is phi, and this is used to denote an empty set, or we also call empty set as what? Null set. S is equal to null set. This is also what we can write. So there are three ways in which we can represent a empty set. So either you can write two curly brackets with no elements inside it, this will mean an empty set, and phi will also mean an empty set, and also if you just write null set, then it will also mean an empty set. Okay, so this set of the states in India that does not have a state capital, it has no elements inside it. Like I cannot write any state name that has no capital. Every state in India has a capital, right? So this will be an empty set. Now let's take another example. Let's say A is a set. Okay, this is example. Let's say A is a set which is written as x such that x is a natural number. Okay, this is a x is a natural number, and this x, it lies between 1 and 2. Okay, now try to write this set. This is a set that has been written in the set builder form. See, x such that x, if A is in roster form, then the elements, all the elements or each of the element has been considered to be x for some time. And what is the nature of this x? X is a natural number. So natural numbers are what? 1, 2, 3, 4, 5, like that. All of these are natural numbers. So x should be a natural number, and it should lie between what? X is greater than 1 and less than 2. Means x should lie between 1 and 2. But look carefully, is there any natural number that lies between 1 and 2? Because right next to 1 you get 2, and before 2 you get 1. So there is no element in between 1 and 2. So this will be a null set, or we can denote it as A is equal to phi, or A is a null set. Okay, it's an empty set. So I hope all of you got to know what is an empty set and how we represent an empty set, either by this or by just writing it as null set. Alright, now let's talk about finite sets and infinite sets. Okay, finite set and infinite set. What is this? Okay, let's see. So what do you mean by the word finite? Finite means something that we can count, like you can count the number of students in your class or in the entire school, right? But tell me that can you count the number of stars in the sky? No, right? That is an infinite number. So infinite is something that cannot be counted, okay? Cannot be counted. And finite is something that can be counted, okay? So talking about finite sets, okay, let's talk about finite sets. So talking about finite set is a set which or in which we can count the number of elements present, okay? So in the set in which, okay, we can count the number, NO means number of elements present. Okay, for example, let's say if I give an example, there is set B and the set B is 2, 4, 6 and 8. Okay, the set B has these elements. Now let's say there is another set S, the set of subjects in class 11. This was an example that I gave you in video number 1. So English, then you have maths as a subject in class 11 if you are 11 science, then you have physics, then you have chemistry, and then you have a elective subject, and this can be physical education or computer science or geography or statistics or anything. Okay, so let's take another set C, which is what? The set of total number of people in this world. So if you look carefully, in the set B you have 4 objects, 2, 4, 6 and 8. Just count them, 1, 2, 3, 4. There are 4 objects or 4 elements which can be counted, right? So this is a finite set. Now the set of subjects in class 11 science, the subjects are what? English, maths, physics, chemistry and elective. You can count them, 1, 2, 3, 4, 5. There are 5 subjects, so this is also a finite set. And if you see the set of total number of people in this world, it is a big number. If you go on to count the total number of people living in this world right now, this will be a very big number, but yes, you can count it. So this is also a finite set. Okay, so these are the 3 examples that I have given you of finite set. Now let's talk about infinite sets. Okay, so what is an infinite set? Infinite sets are those sets, okay, those sets in which we cannot count the number of elements present. Okay, so for example, if I say S is a what? Set of all the stars in the sky, okay, and I give you another example as P is equal to number of points or set of points in a line. Now if you see S, this set S is what? It is a set or it is a collection of all the stars in the sky. But do you know or can you count how many stars are there in the sky? No, right? That is a very big number. You can go on counting. So this is an infinite set. Okay, then P is what? Number of points in a line. If you draw a line and try to count the number of points, it will be infinite number of points, a lot of points. So this is what? An infinite set. Okay, if I give you another example, the set of natural numbers, if I write, then what? The natural numbers, they start from 1, 2, 3 like that, 1, 2, 3, 4, 5 like that, and it goes on as long as you want to write. So this is what? Infinite number of elements in the set of natural numbers. Okay, so this is also an infinite set. So I hope all of you got to know what is a finite set and what is an infinite set. Always remember that a set is finite when the number of elements in the set is countable. We can count the number of elements, and a set is infinite when the number of elements in the set is uncountable. Okay. All right. Now, the next type of set we need to discuss is equal set. Okay. Equal set. Now all of you should know that the word equal or unequal is used when we compare 2 or more things, right? Like when we compare 2 things, if this is equal to this, then we'll say equal. If they are unequal, then we'll say it's not equal. Okay, so if I give an example here, like let's say if you have 10 rupees in your pocket, okay, 10 rupees in your pocket, and your friend has 15 rupees in his pocket, then what I can say here is that both of you have unequal amount of money, because you have 10 rupees and your friend has 15 rupees. Had it been like this, that you have 10 rupees, okay, and your friend also has 10 rupees, so when I compare how much money both of you have, I'll say what? Both of you have equal amount of money. Here, both of you don't have equal amount of money, so it will be unequal, okay. In the same way, when we compare two sets, here I've compared the amount of money you had and your friend had. So when we compare two sets or more than two sets, we will decide if they are equal or not. Now the question comes, how to determine, or on what basis do we decide if two sets are equal or not? Okay, so please make sure to note down this. Okay, this is a note of important point. This is a condition, in fact, for the equality of sets. Okay, so the first is, alright, let me give you the statement. Two sets, okay, two sets are equal only when the first point is the number of elements, number of elements in first set is equal to the number of elements in the second set, equal to the number of elements in the second set. Okay, and point number 2 is that each element of first set should be same as the elements in the second set. Means the first set has some elements, it should be same as the second set, the elements of the second set, only then it will be equal. So keep in mind that only if these two conditions are fulfilled, the first condition and second condition, only when these two conditions are fulfilled, we'll say that two sets are equal, and if not, if any of the condition is not fulfilled, then the set is not equal. Alright, let me give you some examples. Example number 1. Let's say we have two sets. A is equal to 1, 2, 5, 7 and 9. So the set A has these elements 1, 2, 5, 7 and 9, and set B has these elements 1, 2, 5, 9 and 7. So now we need to decide if A is equal to B, that is set A is equal to set B, or if set A is not equal to set B. Okay, so in order to decide this, let's check the first condition. It says the number of elements in first set is equal to the number of elements in the second set. So let's check how many elements are there in the set A. 1, 2, 3, 4, 5. So there are 5 elements in set A. The set B also has 1, 2, 3, 4, 5. So there are 5 elements. So the first condition is good to go. Okay, so the first condition is fulfilled. Let's check the second condition. Here it says each element of the first set should be same as the elements in the second set. So the elements in set A are 1, 2, 5, 7, 9. Okay, the elements of set B are what? 1, okay, this is same, 2, this is same, 5, this is same, 9, this is same, 7, this is same. That is, each and every element of both the sets are same. So both the conditions are true. That means set A is equal to set B. So this is what we will write. Set A is equal to set B. Now let's take another example. Okay, let's say A is equal to PETER, or you can say the set of this set A is a set of letters of the name Peter. Okay, Peter is the name of a person, right? So we are writing the set of letters in this word Peter, and set B is equal to, let's say, ETRP. Okay, now we need to decide if set A is equal to set B, or if set A is not equal to set B. Okay, so these are the two conditions. Let's check it. The first condition, the number of elements in first set is equal to the number of elements in the second set. So check here, the number of elements are 1, 2, 3, 4, 5, and here 1, 2, 3, 4. Elements are unequal, but wait, here this is what? PETE. This E has been repeated twice, right? So I'm sorry, so here we remember from the first video that elements in a set, when it is denoted in the roster form, this is the roster form of representing a set, the elements cannot be repeated, right? So this effectively can be written as A is equal to what? PE, will not use the second E, then T, then R. Now check for the first condition. There are 4 elements here, there are 4 elements here. Okay, the first condition is good to go. Check for the second condition. The second condition says that each element of both the sets should be same. So P, you have a P here. You have a E, you have a E here. You have a T, you have a T here. You have a R and you have a R here. So each and every element is also same. The number of elements is equal. Both the conditions are fulfilled. So set A is equal to set B. Okay. So I think this is enough for you to understand. So let's take another example. I think it will be more clear about you, or else this is fine. Okay, now let's go ahead and talk about, okay, let's take another example. Let's say we have a set A is equal to x such that, this is an example, okay, x such that, I'm writing it in the set builder form now, x such that x is a whole number and whole number and x is less than 10. Okay, and b is equal to 1 2 3 4 5 6 7 8 9 and 10. Okay, these are the two sets. Set A is what? X such that this is what? X. We have assumed that whatever elements that A has, each of the element has a nature that each of them is a whole number, X is a whole number, and X should be less than 10. So what are the elements? Try to write it in the roster form so that we can check each and every element and decide if A is equal to B or if A is not equal to B. So X such that X is a whole number. So whole numbers, they starts from 0, right? 0, 1, 2, 3, 4 like that. So the first whole number is 0, then 1, then 2, 3, 4, 5, 6, 7, 8, 9. And I'll not include 10 because it says X is a whole number and X is less than 10. X is less than 10. So I'll not include 10. I'll just keep until 9. And the set B is what? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Alright, now let's go ahead and try to compare these two sets and check if these two conditions are true or not. Count the number of elements to check the first condition. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first condition is good to go. There are 10 elements in each of them. Okay. Now, each element of both the sets should be equal. But if you check here, 0 is present in set A, but it's not present in set B. Similarly, the number 10 is present in set B, but it's not in set A. So clearly, you can see that all the elements of set A and set B are not equal. That means the second condition is not fulfilled. So I'll say set A is not equal to set B. Okay, if any one of the condition is not fulfilled, then the set will become unequal. So I hope with these three examples that I have given you, all of you have understood what is an equal set, or when exactly we can say that two sets are equal. Always remember that two sets are equal only when both the conditions, okay, that I have given you is fulfilled, or both the conditions are true. Okay. Alright, now let us go ahead and do some examples given in your book and apply whatever we have learned today. Okay, see if I've got the sheet or not. Yeah. Okay, now these are all the examples that has been mentioned in your book. So we'll do it now. The first question is mention each of the sets mentioned below. Okay, these are the sets A, B, C, D is an empty set or not. So we need to decide if the sets A, B, C and D are empty set or not. Okay, so let's look at the first set, and if you notice, all of them has been written in the set builder form, x such that, x such that, x such that, x such that. Okay, so the set A, it says x such that x is greater than 1 and less than 2, right? This is x greater than 1 and less than 2. That means x is a number that lies between 1, the number 1 and the number 2. And what is the nature of x? X is a natural number. So natural numbers are what? 1, 2, 3, 4, 5 like that. Now tell me, if I try to write this set in the roster form, I'll put an open bracket, okay? And then I'll try to write the elements. But if you look here, the condition says x is a number that lies between 1 and 2. And x should also be a natural number. Tell me, is there any natural number that lies between 1 and 2? No, right? Because right next to 1 I get 2. So there is no natural number in between 1 and 2. So this is an empty set. Or I can write this, or I can write A is equal to 5. So this is an empty set. Now let's talk about the second one. B is equal to x such that x square minus 2 is equal to 0. This is some kind of a equation, and it says that x is a rational number. So first of all, tell me, what is a rational number? If you don't know, let me tell you, then rational numbers are simply fractions. Okay, I can say that rational numbers are of the form p by q. P can be anything, q can be anything. Okay, but q cannot be it's not equal to 0, because if q is 0, anything upon 0 will become infinite. Okay, so if you look here, the equation, it says x square minus 2 is equal to 0. If we try to solve this, x square is equal to 2. That implies x is equal to plus minus root under 2, and this cannot be solved any further. And is this a fraction, or is this a rational number? No, it's not a rational number. So for this set B, this is also a what? Empty set. B is equal to 5, because we don't have any value of x that is a rational number. Whatever we get is an irrational number. Root under 2 is irrational here. Plus root 2 and minus root 2, both of them are irrational numbers. Okay, so this is also an empty set. Now let's look at the example number 3 here. It says C is equal to x such that x is an even prime number. Okay, it should be an even prime number. So what are the prime numbers? It starts from 2, then 3 is a prime number, 5 is a prime number, 7 is a prime number, then you have 11 and so on, right? So these are all the prime numbers. It says x is an even prime number. So what is the even prime number? This is 2. Okay, 2 is the only even number that is also a prime number. It says greater than 2. So is there any even number that is also prime and that is greater than 2? No, right? Because there is no other even number in the list of these prime numbers. Always remember, in the list of prime numbers, there is just one even number, and that is 2. And there is no other even number. All of them are odd. So when it says x such that x is an even prime number greater than 2, so I can say that there is no even prime number that is greater than 2. So this is also an empty set, or C is equal to 5. Okay. Now D is equal to x such that x square is equal to 4. X square is equal to 4. Okay, this is the equation, and x is odd. So try to solve this equation and find the value of x. It should be odd. Okay, so that implies x is equal to, when you remove the square, it gives plus minus root under 4. And when you solve this, plus minus root under 2 square. And when you remove the root, plus minus 2 square. And when you remove the root, it gives you a half in the power, so 2 and 2 gets cancelled, so it's plus minus 2. So either x is equal to 2 or x is equal to minus 2. X has got two values, but check if x is odd. Here it says x is odd, but x is not odd. 2 and minus 2 are even, so D is also an empty set. Okay, or D is equal to 5. Had it written here x is even, then yes, we would have some answer, and this set D would not have been called as an empty set. But the values of x, none of them, this or this, is odd. Okay, now let's move on to the second question here. Here it says state which of the following sets are finite and infinite. And see here, all of them has been mentioned in the set builder form. So we'll try to see and write the sets in the roster form so that we can check each of the elements if it can be counted or not, because finite means the elements of a set can be counted. That set will be called as a finite set, and infinite set means elements of a set cannot be counted. Okay, so let's try to write the first set in the roster form. Okay, because in the roster form we get to know what are the elements, or which are the elements. Okay, here it says x such that, okay, there is x, let's write the name of the set to be A. Okay, so x belongs to n. Now this capital N means natural numbers, okay, in maths. So natural numbers are 1, 2, 3, 4, like that. And x minus 1, x minus 2 is equal to 0. So this is the equation, x minus 1, x minus 2 is equal to 0. So the multiplication of these two terms is equal to 0. So either this is 0 or this is 0, or both of them are 0. So x minus 1 is equal to 0, or x minus 2 is equal to 0. So if x minus 1 is equal to 0, then if you take the 1 on the other side, then x is equal to 1. And if you take minus 2 on the other side, then x is equal to 2. So I can see that I have two values of x, 1 and 2. And this 1 and 2 is also a natural number. So this set is what? 1 and 2, the elements of this set, okay? Because when I solve this equation, I get the values of x, and this x belongs to natural numbers. Yes, 1 and 2 belongs to the natural numbers. So this is a what? Finite set. This is not infinite, because there are just two elements. Now the second question, x such that x belongs to natural numbers once again, okay, and x square is equal to 4. Now solve this equation and try to find the value of x. X square is equal to 4, so x is equal to plus minus root under 4, and if we solve it, plus minus root under 2 square, so it will be x is equal to plus minus 2. That is, x can be either plus 2 or x can be either minus 2. Now tell me, x such that x belongs to natural number. Minus 2 is not a natural number, and x square is equal to 4. When we solve this equation, we get two values of x, and one of them, plus 2, is a natural number. So this set, let's say it to be b is equal to 2. There is just one element, will not include minus 2. Why? Because minus 2, or this value of x, minus 2, is not a natural number. Natural number do not include the negative numbers. Integers, they include the negative numbers. Okay, so this set is also what? Finite. Now let's look at the next one. X such that x belongs to natural numbers once again, and x is prime. Okay, what are the prime numbers? I think this question is wrong. Let me check the question from the book once, because alright, x such that x belongs to natural numbers and x is prime. So this is a correct question. Okay, so let's write the prime numbers. Prime numbers are 2, 3, then you got what? 5, then you got 7, and then you got what? 11, 13, and so on. So all these are what? Natural numbers also, because natural numbers, they start from 1, 2, 3, like that. It goes on. And in this set of numbers itself, these numbers will lie. So what if we focus on this one? Okay, let's say this is a set C, then C will be what? The first element is 2, because it says x should be a natural number and it should also be a prime number. So 2, 3, 5, 7, and so on. You will go on writing. So this is what? Infinite set. Okay, infinite set, because there will be infinite number of elements. We cannot count them, okay, if we go on writing. Now the next is x such that x belongs to natural numbers once again, and 2x minus 1 is equal to 0. So x should be a natural number, and this is the given equation. So try to solve the equation. 2x minus 1 is equal to 0. So 2x is equal to 1. I'll take the 1 on the other side. So x is equal to 1 upon 2. Now tell me, is this value of x, that is half, is it a natural number? Because natural numbers are 1, then 2 directly, right? Half will lie between 1 and 2. Or half will lie before 1, 0.5. Half is what? 0.5, right? So half is not a natural number. So this set, if I call it to be D is equal to what? Phi, or a null set. That means there is no elements. That means this is a finite set. Okay, don't get confused. Why this is a finite set? Because there is no element. So if somebody asks you how many elements are there in this set, you'll say 0 elements. That is 0, you can count what? Right, 0 element, no element. Okay, so this is finite. Now let's look at the next one. X such that x belongs to natural numbers and x is odd. So it should be a natural number. Okay, natural numbers are 1, 2, 3, 4, 5, 6, and so on. And odd, what is an odd number? It is 1, 3, 5, 7. So if you fulfill both the conditions, then this set, let's say to be E, then E will look like what? 1, the first odd number. It should be natural and odd. 1 is natural number and an odd number also. Then 3 is a natural number and an odd number also. 5 is a natural and an odd number. 7, and so on. It will keep on going. So this is a infinite set. Okay, this is an infinite set. So I hope this question is clear to all of you, how to decide if a set is finite or infinite. Now let's move on to the next question here. Find the pair of equal sets, if any. Give reasons. So these are the sets that has been given to you, and you need to decide if any of the sets is equal, like pair. Okay, if A is equal to B, if B is equal to C, or if A is equal to C, or something like that. Okay, so let's check all the elements first, because to see if two sets, when we compare two sets, and if we need to decide if two sets are equal or not, there are two conditions, right? So these two conditions we can verify only when we know each and every element the set has. So let's go ahead and do this. The first set A has just one element, that is 0. The second set B, see here, it's in the set builder form, x such that x is greater than 15 and x is less than 15. So tell me, is there any number that is greater than 15 and less than 15? No, right? So B is a null set, or phi. Then C. C is x such that x minus 5 is equal to 0. So x minus 5 is equal to 0. Solve this equation, x is equal to 5, right? So this is having just one element, that is 5. And then D, x such that x square is equal to 25. So x square is equal to 25. When you try to solve this, x is equal to plus minus root under 25, and this will give you what? X is equal to plus minus 5, because 5 square, and when you remove the root, there will be a half in the power, and this will get cancelled. So plus minus 5, either x is equal to plus 5 or minus 5. So this set has two elements, 5 and minus 5. Okay, and the last one, E, x such that x is an integral positive root of the equation. Okay, this equation needs to be solved. X square minus 2x minus 15 is equal to 0. So when we solve this equation, this will be what? This is a quadratic equation. So try to break the middle term. So 5 3s are 15. So I can make it what? X square minus 5x plus 3x minus 15 is equal to 0. So if I take x common, x minus 5, and then if I take 3 common, then x minus 5 is equal to 0. So now x minus 5 is common from both of this. So x minus 5 common, then here it will be x, and this will be plus 3. Now either this is 0 or this is 0, right? Because both of them when multiplied is equal to 0, it says. So either x is equal to 5 or x is equal to minus 3. Okay, but see here, I've got two values of x, that is 5 and minus 3, but it says x is an integral positive root. It should be a positive root. What are the roots? 5 and minus 3. So we will exclude this one, will not include this because this is negative. So the set E is 1, E is equal to just 5. We'll just include the positive answer. Okay, now try to compare it, because you have all the elements. Now A has just one element, that is 0. Try to see, is there any other set that has one element and 0 as its element? So this is a null set. This has 5, this is 5 and minus 5, this is just 5. So A cannot be compared with anyone. B is a null set, and rest all the sets has at least one element in it. C has 5, and if you compare C with D, D has two elements. No, this is not equal. E has 5. Now both of these sets, C and D, have one element each and the same element, that is 5. So C is equal to D, because both the conditions are fulfilled. If you go back, the number of elements in the first set is equal to the number of elements in the second set. Yes, this has one element, this also has one element. Each element of first set should be same as the element in the second set. The element in the first set is 5, in the second set is also 5. So both of them are equal. And rest, D is not equal to any of them because D has two elements. So this is the only two sets or a pair that is equal. Okay, now let's move on to the next question here. Which of the following pair of sets are equal? We need to decide if the sets are equal or not. X, what is X? X is the set of letters in alloy. Alloy is a word. So try to form the set in roster form. Okay, X is equal to what? Alloy. So the letters in this word alloy are A. I'll write A. I'll write L. Okay, then I'll write L once again. No, I'll not do that. We are not supposed to repeat a element, okay, when we write it in the roster form. So I'll just include one L, because there are two L's. I'll just write 1, then O, and then Y. So this is set X, the set of letters in the word alloy. Now the set B is what? The set of letters in Lowell. Okay, this is a word Lowell, and we need to write the set of letters. So let's try to write it. L, okay, L. O, okay, O. Then Y, okay, Y. And then A, okay, A. And L, since we have already included it once, so this is it. Okay, now try to compare. It's asking if they are equal or not. Okay, now the set X has 1 2 3 4 elements. The set B has 1 2 3 4 elements, right? Both has same number of elements, so the first condition is good to go. Let's look for the second condition, if each of the elements are same or not. Check the first element. A is present in the second set also. Okay, L is also present here. O is also present here. Y is also present here. That means each of the element in the first set is equal to the second set, is same as the element that is present in the second set. That means the second condition is also fulfilled. So we'll write what? The set X is equal to set B. This is your answer. Okay, now let's look at this one. Since here it says justify, so I'm explaining this to you. Okay, in the exam also you need to write according to your own statements. Okay, or simply write this, the teacher will get to know. Okay, now A is what? It's written in the set builder form, N. So don't get confused why they have used N. we can use x or y or z or anything. So they have used n, and they have defined this element n to be what? N belongs to z, and z means what? Integers. Okay, the set of integers. And what are the integers? Remember this number line. When we say integers, there will be a 0 at the center of this line. On the right hand side of 0, you have got all the positive numbers, 1, 2, 3, and so on. And on the left hand side, you have got all the negative numbers, -1, then -2, then -3, and so on. Okay, so this is all the integers. So here it says n such that n belongs to the integers and n square is less than 4. So if I try to write the set A in the roster form, then what will be the elements here? So n should be an integer. Okay, so if I take n to be 1, then if I do n square, then 1 square. Okay, let's write it here. If n is equal to 1, let's say, then n square is equal to what? 1, because 1 square will be 1. If n is equal to 2, I have taken this one, okay, and then I'll take 2, then n square is equal to what? 4. If I take n is equal to 3, then n square will become 9, but this cannot be accepted because n square should be less than or equal to 4. So n can be 1 or 2. But since this is talking about integers, we'll have to check for the negative numbers also. So if I take n is equal to 0, okay, I have taken 1 and 2 on the positive side, I'll take 0 now. N is equal to 0, then n square is what? 0 square is also 0, which is less than 4. Okay, we can include 0. N is equal to, let's say, we'll take -1. So n square will be what? -1 square is what? +1. So this gives me 1. And 1 is less than 4. Yes, this is correct. And n is equal to -2. If I take, then n square becomes what? 4. Right? Because -2 whole square minus 2 times gives you plus, and 2 times will give you 4. So this 4 is also equal to 4. That means this condition is fulfilled. And if I take n is equal to -3, that is this one, then n square will become 9, and this is not supposed to the condition. Okay, so the elements in this set are what? -2, -1, 0, 1, and 2. Okay, remember how I've done this, or just look carefully how I have done this. Okay, now the set B is what? X such that x belongs to R. R means real numbers. Real numbers include all the numbers, all the decimal numbers, all the fraction, natural, whole numbers, and everything. So real number, and x square minus 3x plus 2 is equal to 0. So this is the equation. X square minus 3x plus 2 is equal to 0. So if I solve this equation, I'll get the values of x. So let's try to solve this. X square minus, I'll break this term, 2x minus x plus 2 is equal to 0. So if I take x common, x minus 2, and if I take a -1 common here, then x minus 2 is equal to 0. Then if I take x minus 2 common, I hope that all of you know how to solve quadratic equation. I'm solving this too fast, and if you are confused, please do mention it in the comment section below. Okay, so this is it. Now either this is 0 or this is 0. So x minus 2 is equal to 0, or x minus 1 is equal to 0. So x is equal to 2, or x is equal to 1. So I've got two values of x. So this set is what? 1 and 2. Now try to compare. The set A has how many elements? 1, 2, 3, 4, 5. And the set B has 2 elements only. So the first condition is not fulfilled. So I can straight away say that set A is not equal to set B. So this is it for today. I hope that all of you have understood what I have taught about empty set, about finite and infinite set, and about equal set, and when two sets, or what are the conditions when two sets are called to be equal. Alright, thank you so much for today, and we'll see you in the next video.